So now we're in part 3 of the exponent videos. Right now we covered the multiply and the divide in the first 2 parts. Now we're going to go through the power of exponents. So it's exponent on top of exponent. Pretty interesting. So the theorem says that x to the a power to the b power is you just multiply it. You just multiply exponents. That's all you do. Okay? And pretty simple as long as they have the same base. Remember, that's the key thing. They have to have the same base. So you don't want to get tricked and there's a different base and then you multiply, that won't work. So it has to be the same base. So let's do number 1. So we have x cubed to the 5th power. So what do we do? See power on power. So what we do here, we multiply, right? So x to the cube to the 5th power, so you just multiply 3 times 5. And you'll get x to the 15th power. Pretty good, simple problem. And as my problems always go, they go from easiest to hardest. And that's how you get challenged, and that's how you really grasp the subject. Because you just memorize the easy things, and then something challenging pops up, you're going to be lost. And that's what a lot of teachers, especially the higher end teachers, like to do. So number 2, you have 4 to the 5th power to the negative 4 power. So I changed up a little bit. Now there's a negative exponent. Oh no, what do you do? Same thing, you follow the rule. What does it say here? Base, okay, and to the power, to another power, you just multiply it. So same thing. So I will go 4 to the 5th power, so 5 times negative 4, which is negative 20, right? The thing is, you don't want to write it with a negative exponent. A lot of teachers don't like that. So if you want to be safe, change the negative exponent to a positive exponent. And what do? You flip over, do the reciprocal, right? So this will be just 1 over 4 to the 20th power. So this is a better way to write it. 1 over 4 to the 20th power, any math teacher will take, okay? Number 3, we have 5 to the x power to the 4th power. See, now it's a little weird. Now I put the exponent as the x instead of x being the base. So what do? That looks a little weird now, right? Same thing, right? You just multiply them together. The rules don't change. So 5 to x to the 4th power is the same thing as 5 to the x times 4, which is just 5 to the 4x. Okay? That's all you do. It's the same thing. There's nothing tricky about it. It's just, you just got to follow the rules, okay? So here's another one. This is another one that's a little crazy. 3 to the y power to the x squared power. So now you have an exponent on another exponent on another exponent. It's like, okay, what do you do with this? Okay? So what you do is the same thing. You multiply them together. So I'll just go 3 to the y x squared. Okay? Because the rule says just to do that. Okay? And that's it. Nothing else. So number 5, you get 4 to the root 2 power times to the root 6 power. So what do you do there? Well, the rules here says that you multiply the exponents, right? When you get power to on top of power. So we do the same thing. So 4 to the root 2 times root 6. Okay? And root 2 times root 6, if you remember radicals, if you haven't learned it, I'm going to make a video very shortly about it. You just multiply the numbers in here, and you get root 12. Okay? 4 to the root 12. But of course you can't leave it at root 12 because root 12 has a factor in it. And I'll expand it if you haven't covered it. It's 2 times 2 times 3, right? So 2 can really come out because 2 times 2 is 4. And the square root of 4, is really 2. So answer is really 4 to root 3. Okay? So that's the answer. Okay, for that one. Number 6. What if you have something like this? 7 to the 1/2 power to the negative 5/2 power. So now you got fractions and then you get a negative fraction on top of it. What do? You do the same thing, right? The rules don't change. So you get 7 times 1/2, okay, times negative 5/2, okay? And then that will be 7 to the negative 5/4 power, okay? And then the way you rewrite that is that since you don't want a negative exponent, let's move it to the bottom. And then you get technically, since it's 5/4 is greater than 1, you can rewrite it the same way like this. And do you remember why you can do that? Look at the first one. Isn't it look the same? 7 to the 4/4 times 7 to the 1/4, right? Look at the same base. You add it together. You see how it all comes out? Okay? So this 7 to the 4/4 power, 4/4 is just 1, right? So 7 to the 1 power is just 7. So you can rewrite it like this. And if you don't understand this, believe me, we're going to go over the radical chapters, and you'll understand it. I'll make another video for that. So it's 7 to the, to the 4th root of 7. It's okay if you haven't covered this yet, and I'm going to have another video for that. We're going to get really deep into how radicals work. And I'm supposed to actually rationalize that. Let's see. So it will be 1 over 7. Let's see, 4 root 7. So you want to rationalize the bottom. And you will get, what, this is 7, right? If you get 4th root 7, 7 times 7 is 49. Okay? And then the top is just seven cubed, 4th root of 7 cubed. I know it's a very complicated looking answer, but sometimes, like I said, numbers, they don't come out as clean as you want it to, but you want to get used to that kind of idea, because as long as you can defend how you got the answer, no math teacher in the world will ever turn you down. And this is considered one of the harder problems, so if you don't understand this particular problem right now, it's okay, because I'll cover radicals with you more extensively. This one, I want to cover more of exponents, but the general idea is I want you to understand that when you get power on power, you always multiply. Okay? And we're going to move on to another lesson where it's combine all three of these concepts, and we'll do a little more challenging problems. Okay.